Hi everyone, welcome to your last week of distance learning. In this last section we're learning how to factor. This time we're learning how to factor when that leading coefficient is no longer 1, right? Before we were doing something like this where we had x squared as our leading term, but now I have a 3 in front of that x squared. So we're going to learn using the x method. So I know last section we said we had two options. The x method works the best for when your trinomial doesn't have 1 at the beginning of it, when it has another number. So step 1, right, we're going to make our x. In the top of our x, we're going to take this term here, our c term, we're going to multiply it by that leading coefficient. So we would put 3 times 4, which is going to give us 12. And in the bottom, we put that middle term, we put the 8. So we are still doing kind of the same thing we did last section. We're looking for two numbers that will multiply together to give me 12, and they'll add together to give me 8. So if I list out my factors of 12, I would have 1 in 12, or I could have -1, -12. I could have 2 and 6, I could have -2, -6. I would have 3 and 4, and I could have -3, -4. So out of this list of factors here, the only pair that will add up to 8 is my 2 and my 6. That goes on the left and the right side. So what's differing from last section is once we had this, it was really easy from here to get our answer. We just made the two binomials. In this case, when we have a leading coefficient that's not 1, all these two numbers are telling us are how we are going to end up splitting up this middle term as we rewrite it. So we're going to rewrite our equation, 3x squared. Now we're breaking this 8x into two different terms. We're going to say plus 2x plus 6x. And I'm getting the 2 and the 6 from my left and my right sides of my x here. And then I have plus 4 at the end. So from my first equation to my second equation, those are the two pieces of information that changed. And we can tell, right, this is still equivalent to this top equation because 2 plus 6 will give me the 8x. All we did was this is telling us how to split it up. From here, I'm going to look at my first two terms and I'm going to look at my second two terms and I'm going to group them. All right, so I'm grouping these together, and as these groups, right, I'm going to take a look at this first group, and I'm going to try to pull out a GCF. So I'm looking at just 3x squared plus 2x. Now I can't pull anything out between my 3 and my 2. They're not divisible by any number, or the same number, right? But I can pull out an x. So my GCF I'm pulling out is an x, and when I do that, I'm left with the binomial 3x plus 2, okay? So this is where that GCF section comes into play. So I just took care of my first group here by pulling out the GCF of x. Now I'm going to take a look at my second group here. I have 6x plus 4, so I can't take out an x because this 4 doesn't have an x to give. What I can do is I can take out a 2 from these coefficients, right? Both of these terms are divisible by 2. So I'm going to pull out a positive 2, and what's left is 3x plus 2. Okay, so this is our whole goal. When we're pulling out the GCF, we're trying to make sure that these two parentheses, these two binomials in these parentheses are going to be exactly the same. And they are. They have the 3x plus 2, 3x plus 2. So this is where we can finally come to our final answer, right? The 3x plus 2, that's going to be one of my final binomials, okay, because it's the same. My second binomial is coming from the GCFs that I took out. So my second binomial is going to be my x plus 2 here. Okay, it's those GCFs that I took out. I'm combining those. Okay, so this is my final factored answer here. I took 3x squared plus 8x plus 4. I factored it to x plus 2 times 3x plus 2. And again, we can always go back to double check to make sure that's actually true, that this answer is actually correct. So we can FOIL this, right? If I FOIL it, I would have x times 3x to give me 3x squared. And then I'd have x times 2 to give me plus 2x. I would have 2 times 3x to give me plus 6x. And then I'd have 2 times 2 to give me 4. And when I combine this, right, I'm going to get 3x squared plus 8x plus 4, which is exactly what we started with at the beginning. So we know that our answer will work, we know that it'll check off, right? And we can still find the roots of these problems. So we could say x plus 2 equals 0 and 3x plus 2 equals 0, right? That's how we find our roots. We would subtract the 2 on the first set here. We would say x is equal to negative 2, right? So that's one of my roots. In my other one, I could subtract the 2. I'd have 3x equals negative 2. And when I divide by 3, I'm going to get that x is equal to negative 2/3. Okay, so it's okay if we have a fraction. So again, going through this again, right? These left and right numbers that we found are just telling us how we're splitting up that middle term. And once we split that up, then we can start to group them, right? Pull out the GCF. Make sure that these two parentheses are exactly the same, okay? If you are pulling out a GCF and these two parentheses are not exactly the same, then we did something wrong. We may have to rearrange some terms, okay? But we always need to make sure that these will be exactly the same, because that's what one of our parentheses, our binomials, are going to be, right? And the GCF, whatever's left over after we take the 3x plus 2, those are going to become the other binomial. Okay, and solving for the roots is the same process that we've been doing. Okay, so that was one example. Let's try a couple more. So again, I have 2x squared plus 13x minus 7. So we're going to set up our x. Remember, the number in the top now is now 2 times negative 7. Make sure you bring your sign, right? So I'm multiplying this last term in my first term. So in the top, I have negative 14. In the bottom, I'm going to have positive 13. So if I list out all my factors of negative 14 again, I'm looking for the pair that's going to end up adding to 13. And we have 2 and negative 7, negative 2, positive 7. So from this list, the only pair that's going to add to positive 13 is this negative 1 and positive 14. Okay, so again, this is just telling us how we are splitting up this middle term. So when I go to write this, I'm going to say 2x squared minus 1x plus 14x, right? Remember, do not drop your x's here. They're super important, right? And then we would have minus 7 at the end here. Okay, so again, this is equivalent to above because negative 1 plus 14 will give me positive 13. So we didn't change our equation really at all. We're just kind of regrouping things. So I'm going to look at this first group here, and then I'm going to look at the second group here. So in this first group, I can just take an x or I can take a negative x. So I'm going to split this up into two different examples. The first one, I'm going to take negative 1x and see what's left over, right? So if I take a negative 1x from these terms, that's going to leave me with negative 2x plus 1. Okay, now I have to try to pull out something here, right, that's also going to leave me with a negative 2x plus 1. Now if I just pull a 7 out, that means I'm going to leave this as a positive 2. I'm looking to make it a negative 2. So I'm going to pull out a negative 7 here. That's going to leave me with negative 2x plus 1 again. And again, that's what we're looking for. We're making sure that these two parentheses are going to end up matching. So our two binomials, our two factored versions, one would be negative 1x minus 7, and one would be negative 2x plus 1. Okay, so that's all right. Now let's try a different way, right? So if I group this together and I don't want to pull out a negative 1x, I just wanted to pull out a regular 1x, right? Then I'm left with 2x minus 1. And in here, now I want to pull out a number where I'm going to leave 2x minus 1 behind. So now if I just pull out a positive 7, that's going to leave me with a 2x here, right, and minus 1. So again, they're going to end up matching. And then our final binomials, again, we would have 1x plus 7 And then this binomial that's the same here, 2x minus 1. Now these look like two different answers, right? But if I go through and FOIL both of these, I'll still end up with this 2x squared plus 13x minus 7. And we can show that, right? Negative 1x times negative 2x gives me 2x squared. Negative 1x times 1 is going to give me negative 1x. Negative 7 times negative 2x gives me positive 14x. And negative 7 times 1 gives me negative 7. And when I simplify this, I have 2x squared plus 13x minus 7. So that matches our original equation here. We're good with this side. Now we can show the same thing when we're FOILing this side as well. We do 1x times 2x to give me 2x squared. Right? 1x times negative 1 gives me negative 1x. 7 times 2x gives me positive 14x. And 7 times negative 1 gives me negative 7. And again, I'm going to end up with the same answer here. Okay, so we could factor a little bit differently, right? We'll have different binomials, but we'll see we'll still end up with the same exact roots. So even though in this side we pulled out a GCF of a negative 1x, and over here we pulled out a GCF of a positive 1x, we should still end up on both of these getting the same roots for these equations. So we can show that, right? If I have negative 1x minus 7 equals 0, and negative 2x plus 1 equals 0. Okay, so if I solve, right, we add the 7. I have negative 1x equals 7. Divide by negative 1, you'll get x equals negative 7. Over here, you subtract the 1. You get negative 2x equals negative 1. And when you divide by negative 2, right, remember a double negative becomes a positive, you'll get x equals positive 1/2. So we should get these same exact roots when we solve these two binomials over here. So we'd have 1x plus 7 equals 0, 2x minus 1 equals 0. So again, subtract the 7. You'd have 1x equals negative 7, or just x equals negative 7. Over here, we add the 1. We'd get 2x equals 1. And when we divide by 2, we'll get x equals 1/2. So it does not necessarily matter if you're pulling out a negative GCF or a positive GCF. Although these two binomials look a little bit different, these two sets of binomials, we still end up getting the same exact roots at the end of things. Okay, so as long as you're pulling a negative GCF out of the first one, make sure you're still trying to match up these two parentheses, these two binomials in the parentheses. Same thing over here. If you're pulling out a positive GCF, just make sure you're always matching up these two parentheses. That's the most important part, is knowing how to pull your GCF to match your parentheses. Okay? So that was another example. And then our last example, now we have a leading coefficient that's not only not 1, it's negative. So we're going to set this up the same exact way. We're going to say the negative 5 times the negative 1. Remember, you're always taking your signs. So that's going to give me a 5 on the top of my x. The 6 goes on the bottom, right? And the only two numbers that are going to multiply together to get 5, but add together to get 6, are going to be 1 and 5. Positive 1, positive 5. So again, this is just telling us how we are splitting up our trinomial here, our middle term. So we're still keeping the negative 5x squared. Right, now we're going to say plus 1x plus 5x. And again, I'm getting the 1 and the 5 from my left and my right side here. Right, and again, we haven't really changed our equation at all, because if I combine these, I'd get the 6x again at the top. So my equations are equivalent here. So now I'm going to group these together, right? I'm going to look at these two terms, and I'm going to look at the last two terms here. So between the negative 5x and the 1, I'm just going to pull out an x. That's going to leave me with negative 5x plus 1. Okay, so if I look at my second one here, right, I can't necessarily pull out an x, and there's no term that 5 and negative 1 are both divisible by. But I see that this has to become a negative 5 and this 1 has to become a positive in order for these parentheses to match. So here, I'm just going to pull out a negative 1 as my GCF. And then when I do that, I'm going to be left with negative 5x plus 1. So I had to pull out a negative, even though there wasn't a clear GCF here. I had to pull out a negative 1 from here to make sure that my parentheses were going to match, okay? That's super important. So no matter what, you're still going to end up pulling GCFs out, okay? So our terms are going to be, or our binomials would be x minus 1, negative 5x plus 1. Okay, so say if I looked at this again, right, I'm going to split it up like we did with the last problem. Say I look at this again, instead of wanting to just take out an x here, say I did take out a negative 1x. Okay, here I just took out the 1x, here I'm taking out a negative 1x. So this negative 5x squared would become positive 5x minus 1. Okay, and that pretty much matches the second grouping here. Right? So even though I can't take a GCF out, I need to put a placeholder of 1 there. I need to still keep that 1 there because when I go to write my binomial, I can't drop that piece, right? I can't just have negative x and then in parentheses negative 5x minus 1 because when I would go to FOIL that, it wouldn't end up coming out to give me my equation at the beginning. So I have to put the negative 1x plus 1 and then the 5x minus 1, okay? And we already discussed, if I FOILed both of these out, I'm going to get the same exact equation at the top. But say I didn't end up taking this placeholder of 1 out, right? Then I'd have negative 1x, and then I would have the 5x minus 1, right? If I went through and I distribute that, I would get negative 5x squared plus x. And that's not giving me my final answer up here, okay? This placeholder of 1 is extremely important, okay? Even though it looks like you can't take a GCF out, pull out a 1. It's not going to change your parentheses or your binomial at all. It's just going to ensure that when you factor it into these two binomials, it's going to give you the correct answer so that when you do go back and FOIL it to double check, you're not going to get something like this, okay? So just remember, always keep that placeholder if you think you can't take anything out, okay? And same thing, if we ended up going through this and solving, right, I would have x minus 1 equals 0, negative 5x plus 1 equals 0. So on this first one, I would just add the 1, we would get x equals 1. Second one, we can subtract the 1, we get negative 5x equals negative 1. Divide by negative 5, that double negative is going to give me a positive 1/5. Same thing over here, I have negative 1x plus 1 equals 0, and I have 5x minus 1 equals 0. So when I go through this, right, we subtract the 1, we have negative 1x equals negative 1. Divide by negative 1 on both sides, that double negative gives me a positive 1. And over on the second half, we add 1. We get 5x equals 1. Divide by 5, you'll get x equals 1/5. Oops. Okay. So this is how we are going to factor when our trinomial is not leading off with a coefficient of 1. So it's very, very similar to the last section. Again, the only difference is taking these two numbers on the left and right, splitting it up, and then taking out your GCF. And always remember, you have to make these two parentheses match. They have to be exactly the same. As always, just send me an email if you guys have any questions, and I believe this will wrap up our year. This is our last section of the year.